For homework, you're going to be asked to graph pendulum counts versus length. Also, the number of dominoes versus the length of the rubber band, according to the data that you collected in class today. Now, of these four graphs, you were asked to determine which graph or graphs could not possibly represent reasonable data for the count versus the length. Well, people pretty quickly saw that this graph and this graph couldn't, because as the length increases, the count decreases. And here we would have the count increasing as the length increases, and the same here. So now we have the question of which graph might be the best. Okay, if we have points, let's say here, here, and here, we might conjecture a straight line model from these points. Okay, this point's a little high for the straight line, this point's a little low, but naturally we could be off a little in our count, we could be off a little in our measurement of the length, and that would affect the position of these points on the paper. If we have only 3 points, then these 3 points could plausibly indicate a straight line graph. However, straight line graph, as it turns out, doesn't make any sense in this situation. And you should stop for a minute and think about why that is. Okay, well, and we of course discussed this in class. If you don't remember, you should try to figure it out. You should try to think, what is it about this graph that just doesn't work for pendulum count versus length? Well, the kicker is this point here. At this point, you've got some finite length, but you've got a zero count. Zero count corresponds to you pull the pendulum back and you release it and it doesn't go anywhere. That zero count means the pendulum doesn't oscillate. And clearly the pendulum should oscillate no matter what its length, within reason. And certainly if these are your 3 data points, you don't extrapolate to one more data point, length not that much greater than the last one, and expect the pendulum not to oscillate anymore. So straight line graph doesn't make any sense here. Now maybe a point on the y-axis, the vertical axis, could make sense. There could be some limiting, some upper limit on how fast any pendulum can oscillate. Now in the ideal model it turns out that's not the case, but we can't really test that because there's a limit below which we can't build or time a pendulum. Okay, well, here we have 3 points again. Let's say here, here, and here. And we draw a curve instead of a straight line to fit those points. And that curve is more appropriate because the curve can level off and stay away from the horizontal axis, so that the curve could be asymptotic to the horizontal axis, if you recall that term. That makes much better sense, and it turns out that the actual model does predict that. Now, whether this end of the graph here eventually intersects the vertical axis, not going to say right now, but it could be an asymptote, or it could actually hit the vertical axis if there's some actual upper limit to the ideal or actual model. Okay. Another thing that I'll talk about is the uncertainty in these points, but I'll do that in a separate video.